All right, this lesson is going to focus on graphing inequalities and then also solving and graphing for inequalities. First, we're going to just start with graphing various math statements. If you have something like this, n equals -2. If we have a number line, we want to graph the solution or solutions to this equation. So n equals -2, that means you put a dot on -2, and that's the only answer it can be. So there's no arrows coming off of it or anything. It's just -2. It can't be any other number. N has to be -2 and only -2. Now when you start graphing inequalities, the rules change. M is less than 1. 1 is our focal point, so I'm going to put a dot on 1, but I'm going to leave it as an open dot because your solution can't actually be 1. If you put a 1 in for m, 1 is not less than 1. But everything to the left of 1 is a solution. So m can be anything less than 1, but not including 1. Then we have a statement like this. It has the extra line underneath signifying that it is allowed to be the focal point or the target. So I'm going to mark my -3 with a solid dot because that shows that -3 is part of the solution. And then they want anything greater than -3, so it's going to go to the right. Now one thing that's pretty cool, now this only works when the variable's on the left side, but the inequality sign, you could think of it as part of the arrowhead, so it's going to the right. So that's just one trick you can use. Y can be anything greater than -3, including -3, so the target is allowed. For this one, x is less than 4. 4 is our target, our focal point, but it's going to be an open dot since 4 itself is not allowed, and we're looking for things smaller than 4, so it's going to go to the left. So if I put anything under this arrow would make this statement true. If I put a -4 in for x, it would work. If I put a 0 in for x, it would work. If I put a 2, it would work. If I put 3 9/10, which is somewhere in here, 3 9/10 would work. So not just the integers, but anything in between, all these different numbers in between, 2.5, -1.5, those would all be solutions for this inequality. So there's an infinite amount of solutions. X can be anything smaller than 4, but not including 4. So now we're going to talk about solving inequalities. And first of all, the key thing you need to know is solving an inequality is just like solving an equation, except for one thing. If there's a negative coefficient, the inequality sign must be reversed. So looking at these inequalities, which statements will have the inequality sign reversed? You want to focus on the coefficient. So in this first inequality here, the coefficient is the 5. In this inequality, the coefficient is a -5. In this coefficient, we have this negative. That can be considered -1 times n. And this one has nothing, so you could think of it as a 1n. So these two inequalities, as you're solving them, you'll need to reverse the inequality sign. And we'll get more into that. We'll discuss that further in a few frames. We're going to solve and graph this inequality. Before we do anything, will we need to reverse the inequality sign? I don't see any negatives or negative numbers attached to the variable, so no, you won't have to reverse it. So we're going to treat it like we would an equation. We're going to get rid of this -5 by adding 5 to both sides. That ends up working out to a n is less than 3, and then you just graph it. So since it's just the less than symbol, it's going to be an open dot on 3, and it's going to go to the left. That means any number that's under the arrow is going to be a solution for this. If I put in a 0, 0 is less than 3. And if I plug the 0 in the original inequality, 0 minus 5, that works out to negative 5, and that would be less than negative 2. If I put in a negative 6, negative 6 is less than 3, and if I put it up here and work it out, negative 6 minus 5 is negative 11, which is less than negative 2. For this one, am I going to have to reverse the inequality sign? I see a negative 3 multiplying by x. Yes, I am going to have to reverse it. So what you do, as you're getting rid of the coefficient, that's when it gets reversed. I have the negative coefficient. We're going to divide it out, and as I'm dividing out my negative, the inequality sign does reverse. So this one ends up working out to x is less than or equal to negative 4. With the or equal to, that means we're going to use a solid dot on negative 4, and it's going to go to the left. Now let's double check that this works. Negative 4 would be allowed, so negative 4 is less than or equal to negative 4, and if I plug it in up here, back in the original statement, negative 3 times negative 4 is a positive 12, so it's greater than or equal. Let's plug in negative 6, just to make sure we're good with this. Negative 6 is less than or equal to negative 4, and I'm also going to plug it up here. Negative 3 times negative 6 would be positive 18, which is going to make this true. So we've got another inequality. Maybe you can try solving for it and figuring out what it would look like on the graph. You could pause it if you want right now. Are we going to need to reverse the inequality? No. You just divide it out. Notice how the inequality is staying exactly the same. We're dividing out the 7. It's going to be m is greater than or equal to negative 6. So that's going to be solid dot on negative 6 and going to the right. So negative 6 would work. I'm going to plug in a 0. According to this arrow, the 0 is under the arrow. So 0 should work. I'm going to plug in the 0 here. 0 is greater than or equal to negative 6. And I'm also going to plug it in up here. 7 times 0 is 0. Is 0 greater than or equal to negative 42? It sure is. Negative a is less than 2. This one can get confusing. Will I reverse the inequality? Yes, because I have that negative. You can think of it as negative 1 times a. And then as you're dividing it out, that's when you would do the reversal. So you divide it out, the negative 1's cancel. 2 divided by negative 1 is negative 2. So a has to be greater than negative 2. It's going to be an open dot on negative 2. An open dot, and it's going to be going to the right. It has to be greater than negative 2. Negative 2 itself can't be a solution. But if I put in a positive 4, let's just double check. 4 is greater than negative 2. And if I put it in up here, negative 4 is less than 2. That one can get tricky since there's no actual number, but it's an invisible 1. That's that multiplicative identity happening. So we have some two-step problems here. We've got some multiplying and subtracting. For this problem, will I reverse the inequality? I don't see a negative coefficient, so no. We're going to get rid of my negative 3 by adding 3 on both sides. So you can have 5n is greater than 20. Then, just like we did with equations, you're going to divide out the 5, and you're going to get n is greater than 4. So this will be what kind of dot? Open or closed? It'll be open at 4 and going to the right. Open at 4, going to the right. So 4 itself won't work, but I'm going to plug in a 5 just to see if it works. So 5 is greater than 4, and then I'm going to plug it in here. 5 times 5 is 25, minus 3 gives me 22, which is greater than the 17. Go ahead and see if you can figure out this one, if you want to pause it. Will I reverse the inequality sign? Yes, because we have that negative coefficient. But first we're going to get rid of that constant by subtracting 7 from both sides. Notice how I haven't reversed the inequality yet. and that's going to be negative 4y. 31 minus 7 is 24. So now when I divide out the negative 4, that's when this is going to reverse. So that final answer is going to be reversed. 24 divided by negative 4 is negative 6. So solid dot on negative 6 and going to the left. So it's going to the left. That means 0 would not be a solution. Let's see if this is true. 0 is not going to work for that. If I put a 0 in, that'd be 0. That would all work out to 0 plus 7. And 7's not greater than 31. So anything over here, negative 6 or anything smaller, would work. And that's about it. I hope this helps. Best of luck to you.